the Mr. Harris Math Show. The one, the only, the fabulous. Don't forget to like and subscribe. Okay? So, moving into chapter 9, it's going to be a lot of quadratics. Alright? Outside of factoring, I would say this is probably one of the most important chapters that we're going to deal with because quadratics show up so often in so many forms as you move through higher levels of mathematics. Okay? So, we're going to start with the process called completing the square. Completing the square is something that shows up when we cannot factor a quadratic. Up until now, we factor the quadratic in order to solve. If we can't factor the quadratic, we have to use other means in order to solve for x. Now, completing the square, or the process of completing the square, ends with what we call the square root property. When we complete the square, our goal is to get a binomial square. When I have something being squared, if I want to solve for that value, I can square root both sides in order to get the solution. So if I had a squared equals 16, what value of a can I plug in that makes that statement true? 4. What else can I plug in? Negative 4. I have the positive and the negative option. So when we are using the square root property, and I'm given an equation and I said, hey, I need to square root that. If I square root it, I have to remember that I have a positive and a negative answer that goes with that variable, because both of those values would make that statement true. Okay? So all of these we're going to be using the square root property. When we're using square root property, the most important thing to remember is that whatever is being squared has to be isolated first. So if there's anything else around it, outside of any groupings, we need to make sure that we isolate it first. Well, x squared is the only thing I have, so I can just 7 and negative. So I can go ahead and square root both sides. The square root of 49 is positive and negative 7, or you can write it separately as 7 and negative 7. Either way is fine, depending on your solution. Okay? Now again, it's making sure that whatever is being squared is isolated. So I have the binomial y minus 3 squared. Do I have anything else outside of that on the same side of the equation? No. So I can use my square root property in order to get rid of the radical around that binomial. So y minus 3 equals what? And negative 2. You have both positive and negative 2. But now I'm not done because I still don't know what y equals.
So you would add 3 to both sides.
Add 3 to both sides, but now because I have positive and negative, that means I'm going to have 2 equations now.
So yeah.
I have y minus 3.
So y equals 5 and y equals 1.
I have a positive 2 and a negative 2 for that equation as a solution. So when we add 3 to everything, y equals 5 and y equals 1. So y equals 5 and 1. So that's going to be the big thing, is remembering that we have 2 equations basically. We have one with a positive solution and one with a negative solution. Is the thing being squared isolated?
Yes.
Yeah. So I can go straight into square root property. Okay? So what am I going to end up with on the left?
5
X plus 2. And what else? At both. So x plus 2 equals 5. X plus 2 equals negative 5. All right, so what is x going to equal? Negative 7. X equals 3 and negative 7. Okay, so all of those started out nice and isolated, so that was helpful. But now as we look at the next example, we see that the thing being squared is not isolated. So I need to move everything else first. Okay, what's the first thing that I'll move?
Um,
The 4. By doing what?
Adding 4 to those.
Add 4 to both sides. So 2x squared equals 4. Okay? Alright? Is the thing being squared by itself? Okay? What do I move next? Divide by 2. Is the thing being squared by itself? Yeah. So now I can go into my square root property. I can't square root 2, but it doesn't mean I can't do anything. It just is square root of 2. So I have x equals positive and negative square root of 2. Simplify as much as you can. If you can't simplify anymore, then that's it. You're done. You're not always going to get these pretty nice integer values. We're going to be getting some, honestly, some not pretty values. We'll see a lot more, especially with the last example, is about as ugly as it can get. We'll see how some of that ends up being. Okay? So I've got positive and negative square root 2. All right? Is the thing being squared by itself? So what do I do? Subtract 4 from both sides. It's not no solution.
You'd square both.
Still square root.
Wouldn't it be?
Close. No, there'll be 2. I'll still have positive and negative.
Square root of 2?
How do I simplify a negative radical? So positive, negative, 2i. We have our complex numbers. I told you from now on we can square root those negatives because now we know how to deal with it. With the I. So now I have positive and negative 2i. So I still have 2 answers. They're both just imaginary. For the last one is what I am squaring isolated. Yeah. So we can go straight into our square root property. So 3x minus 17 equals the square root of 28. Can I square root 28? I can simplify it. Yeah. So 28 is 4 and 7. So 2 root 7. Okay. What am I missing? I forgot to put something in there. Plus or minus. See, it happens to the best of us. Don't forget your plus and minus. Alright? Now I need to isolate x. So 3x equals. Are those like terms? No, so I can't actually add them. All I can do is write it. The rational number goes first, a positive 17. The irrational number goes second. Okay, the rational number comes first, 17, plus or minus your irrational number, 2 root 7. Last step, divide by 3. So x is 17 plus or minus 2 root 7 all over 3. That is an ugly looking answer. Actually, I think it's beautiful. It's beautiful in the way that, you know, when you have a baby that has a face and only a mother can love. It's that kind of thing. Well, you know, I think it's wonderful. You all probably hate it. That's about as complex as that number's gonna look. Okay? We will see a fair amount of answers that end up looking like this. Okay? That's just the nature of when we get quadratics that can't be factored. We have these irrational answers. We're going to see these a lot. Not all the time, but not an insignificant amount of the time. So that's our square root property, which we're going to be using a lot. When we are completing the square, which is next, it will end in this process of square root property. Okay? When we complete the square, we are trying to force an equation to look like this, or this, or this. That's what we're going to be forcing out of a quadratic that can't be factored, is something that looks like that. So let's move into the square. The process of completing the square is basically taking a quadratic and forcing it to be a perfect square trinomial. So I want you to recall a couple things. A perfect square trinomial is always in the form where the first and last term are perfect squares, and the middle term is the product of 2 times their roots. Okay? Whenever we have a perfect square trinomial, it always factors to be that same binomial square. So our goal is to force a situation where we can take a quadratic and factor it to be a binomial square. That allows us to do the square root property like we did on the last slide. Okay? So pay attention to this part right here. All right? That is the most important part. My middle term has to be plus or minus 2 times A times B. Okay? A comes from the first term, B comes from the last term. Alright? So 2 times, what's the square root of x squared? X. What does B have to be in order for me to end up with 10x? 5. So B has to be 5. Now my last term is B squared. So what goes in the box? That is now a perfect square trinomial. Perfect square trinomials always factor to be A plus or minus B squared. Well, what was the value of A? Nope. X. That's A. What was the value of B? What was the value of B? 5. And am I going to have plus or minus? Now it's factored. So we are forcing a perfect square trinomial so that we can factor it into that same pattern. Okay? 2A, B. What's the value of A? A is X. A comes from the first term. What's the value? So what does B have to be so that I can what does B have to be so I can multiply those and get 16? 8. 64 is what goes in the box. So B squared is 64. So now we can factor it. X plus or minus? Plus what? 8 squared. Alright? So now let's break this down. What have we been doing? So we took our value in order to find B. What did we do to get 5? How'd you say, okay, I have 10. How'd you end up with 5? Yeah, so what'd you do to 10 to get 5 then? Go backwards. Divide by 2. And then what did I do with that to figure out what goes in the box? Square it. That's our formula for completing the square. We take our B value, we divide it by 2, and then we square it. And that's what gives me the value in the box. That allows me to get a perfect square trinomial. So let's apply that formula here, because both of those were easily divisible by 2. Well, 7's not. And we're going to be dealing with that a lot. Some fractions. Okay? My B value is 7. Okay? I can't simplify that, but that's fine. What's 7 over 2 squared? 49 over 4. So now that is a perfect square trinomial, which will still factor into the same pattern. Is it going to be plus or minus? Minus. Minus what? 7 over 2. Notice how that's the number that went there, that's the number that went there, and that's the number that's going to go there. This process will become very formulaic, and I'm going to inundate you with so many examples that hopefully, anyhow, so you don't cheat, you should be able to repeat it over and over and over and over. It's going to be very, very repetitive. You will see today, it's the same thing, over and over and over. B over 2, squared, factor it, solve. B over 2, squared, factor it, solve. B over 2, squared, factor, solve. It's going to be our process over and over and over. Okay? So this basically describes what we just did for completing the square. I want to just get this out of the way because someone always commented. Several of these examples coming up can be factored normally. We don't have to complete the square. I'm fully aware of that. But sometimes it's nicer to see some prettier numbers than some uglier ones. So just kind of keep that in mind. Always read the directions. If I don't specify how to solve, I would say solve the quadratic. You are free to choose from any of the number of tools that you're going to have at your disposal. We'll have 4 different methods of solving quadratic. But if it specifically says, solve by completing the square, I don't care if you can solve it a different way. You need to solve it by completing the square. Okay? Alright, so step 1 is if we have a coefficient of 1. If we have a coefficient of 2, we have to do something else. We're going to do that tomorrow. Isolate all variable terms to one side of the equation. That's the most important first part. Everything with a variable on one side, everything without a variable on the other. Then we can go through our steps that we did with making a perfect square, and then we can solve. So first thing we want to make sure is that the variables are on one side and the constants are on the other. And that's what we have here. And then we're going to create a gap. And we're going to put squares. We're going to add squares to both sides. I like squares because we're completing the square. Aha! Gives you a little verbal cue. We're completing the square. So we're going to create that gap. We're going to put in those squares. The reason we add to both sides is because it's an equation. Whatever I add to one side, I have to add to the other. Otherwise, it doesn't stay equivalent. So we have to be fair and add the same thing to both sides of the equation. Our goal is to turn this into a perfect square trinomial. B over 2 squared is our formula. What's my B value? 6. What's 6 over 2? What's 3 squared? 9. That's what goes in the box. So now I have a perfect square trinomial. What is this going to factor to be? Yep. Y plus 3 squared. Remember, that's 3. That 3 goes there. Okay. Y plus 3 squared. What's the right side going to be? 1. Okay. Yay, we completed the square. Now we can solve, just like we did on the first slide, using our square root property. Not raise it, square root it. Square root both sides. What's the left side going to be? Y plus 3. What's the right side going to be? And positive and negative 1. So now I've got 2 equations. Y plus 3 equals 1. Y plus 3 equals negative 1. So what is y going to equal? Negative 2 and negative 4. Y equals negative 2 and negative 4. Okay? It's going to basically be that process over and over and over and over. The big difference is just how complex is the answer going to look depending on what's left inside the radical. Okay? I included more examples where we're going to end up with fractions, things that aren't divisible by 2. I figured more fractions help you get more comfortable rather than the whole numbers. Whole numbers are easier. Are my variables on one side and the constants on the other? No. So what do I have to move? The 7. By doing what? Okay. So now we're going to write it as y squared plus y plus a square equals 7 plus a square. What's my b value? Not y. What's the coefficient of y? 1. Okay. Can I simplify 1/2? Now I just go into squaring it. What's 1/2 squared? So the left side will factor. Plus or minus? Plus what? 1/2. 7 plus 1/4. Improper fraction, please. You can use your calculator. Do it for you. It's not pretty. It is what it is. Right? You have a question? You have to have a common denominator, so 7 over 1 becomes 28 over 4. Am I ready to do square root property now? You have to have a common denominator, so this would be 28 over 4. 28 over 4, 7 is 28 over 4. Add it in. Okay. All right, so we can square root both sides now. What's the left side going to be? What's the right side going to be? Square root 29. Can I square root 4? Yes. So, plus and minus. Don't forget the plus and minus. I can't square root 29, I can't simplify it, so it just stays root 29. Now, how do I move that 1/2? Okay, so y equals negative 1/2 plus and minus root 29 over 2. Okay, the rational number comes first, the irrational number comes second. We're adding and subtracting it anyway, so might as well put the plus and minus in the middle. Now, hey look, common denominators. Go ahead and add those. We don't even have to change the denominators. That's going to happen a lot. So they have a common denominator becomes negative 1 plus or minus root 29 all over 2. There's that answer. Okay, we're going to get a lot that'll look like that. Especially when we have numbers that can't be divided by 2 for our b value. Do I need to move anything? Yep. Move the 1. Now what? Over 2 squared. 7 over 2 squared. Yep. So we'll go ahead and square 49 over 4. 49 over 4. Okay. Next. We'll add those in a moment. Quantity squared. Now we can add 1 and 49 over 4. Which gives me what? 53 over 4. Left side? Okay. Yeah. Plus or minus. Combine it over one denominator. See how formulaic the process is? we're going to just have to do a bunch over and over and over and over, and it'll become pretty straightforward. I have one more. Yeah. Do I need to move anything?
Yes.
Don't worry about the negative. Just take that before you square it. Because remember, 9 over 4 is b squared, and then we want b. So we're square rooting 9 over 4 to get back to 3 over 2. We don't need to do it because I already see it, so I just have to write it. What's the right side equal? 5 over 4. Not yet. Square root. Once we square root, then we get the negative and the positive. Okay, can I square root 5? Okay. Notice how our denominator is often 2. It's going to happen a lot, not always. One thing that will change that is if b is a fraction instead of an integer, because we're dividing by 2, right? So if, for example, I had x squared minus 3 halves x plus 1 equals 0, well, b is now a fraction as well. So when we divide 3 halves by 2, I get 3/4. So that's going to end up changing the denominator. Okay? We won't see a lot of fractions, but the process is still the same, and that's what's going to cause little bits of variation. But the process remains the same. b over 2, square it, factor, solve. Okay, b over 2, square it, factor, solve. Do I need to move anything? Actually, I'm going to change this one. Let's make it, let's change that to a negative 4. Just kind of want a little bit of variation. No, this is going to be the last one we're going to stop. Okay, so let's change that to a negative 4. Same process. Do I need to move anything? No. Okay. Okay. Be plus or minus? Plus. Which is what? B was divisible by 2, so we divide it. Okay? X plus 1 squared equals negative 3. Square root both sides. Okay? X plus 1 equals what is the square root of negative 3? Simplify it. Bring that I out. When you got that negative, bring out the I. Okay? Dealing with those complex numbers, as simplified as possible would include no negatives in your radicand. So we're going to bring out the I. If Everything else remains the same. Last thing to get x by itself. Subtract 1. So x equals -1 plus or minus I root 3. There's no denominator because b was divisible by 2. So we won't have a denominator. But we could also have negative radicand. So keeping in mind, simplifying those complex numbers as much as you can. Now, we're not going to do anything after this, but I do want you to look at something. What is a major difference between every example we've done so far and that one? Some of them I did have to move. What's the big difference between all of these examples and this one? No, I can do that. Look at the equation very carefully. We'll have to do an extra step because we have a leading coefficient. I know. We're going to do this one tomorrow, but I want you to notice the key difference. Sort of, yes. I'll explain that process tomorrow. It's a little bit more involved than that, but not much. Okay? So, your assignment tonight will include completing the square and the square root property. And then tomorrow you're going to get another one that's going to be exclusively these types of problems here. And then we'll practice some more on Friday with a big worksheet that mixes everything together. Don't forget to like and subscribe.